Assalamualaikum, my name is Zulfakri bin Ruslan with ID number 18002384. As for today, for the lab 3, I'm going to present an experiment entitled Impact of a Jet. Moving fluid in natural or artificial system may exert forces on objects in contact with it. So to analyze fluid motion, a finite region of the fluid control volume is usually selected, and the gross defects of the flow, such as its force or torque on an object, is determined by calculating the net mass rate that flows into and out of the control volume. And these forces can be determined, as in solid mechanics, by the use of Newton's second law or by the momentum equations. And the force exerted by a jet of fluid on a flat or curved surface can be resolved by applying the momentum equation. There are two objectives for the experiment, which is the first one is to determine the force produced by a water jet when it strikes a flat vane and a hemispherical cup, and the next objective is to compare the results measured with the theoretical values calculated from the momentum flux in the jet and the experimental value. As for the methodology, the momentum force is determined by measuring the forces produced by a jet of water impinging on a solid flat and curved surfaces, which deflect the jet at different angles. As for the procedures of the experiment, first, make sure the weight beam is at balance with the jockey weight at the zero position. Next, start the hydraulic bench and set to maximum flow. The third step is move the jockey weight until the beam balances again, and note that the distance y from the zero position. Next, record the flow rate using hydraulic bench. The fifth step is reduce the hydraulic bench flow in steps to give at least 8 more readings of distance y and flow in relatively equal increments. And the last step is repeat for the other vanes plates that you need. Here is the figure of the experiment setup. So there are two apparatus involved in this experiment, which is the first one is hydraulics bench. The second one is impacts of a jet apparatus with 3 flow deflectors with different angles of 90 degree, 180 degree, 120 degree and 180 degree. And this is the figure of the jet apparatus. So the component in the jet apparatus is weight pane, spring, nut screw, lever gauge, target plate, nozzle, adjustable feet and inlet pipe. As for the result, so this is the raw data table. So we need to note down the volume, time and apply mass for each of the deflection angles, which is 90 degree, 120 degree and 180 degrees. And after that, we need to calculate the nozzle diameter. So the nozzle diameter we use is 0.008 meter, and as for the flow area is 5.0265 times 10 to the power of negative 5 meter squared. So for the nozzle diameter, we can calculate the apply weight. We need to jot down the apply weight, the flow rate and the velocity. As for the flow area, we need to jot down the velocity squared and the force. And then we need to find out the deflector angle, its slope, which is the one theoretical slope and experimental slope. And the theoretical slope, we can use the equation slope equal to rho times area times cos theta plus 1. As for the discussion, the larger the surface of the vane plate, the greater the force that can withstand by the plate, and some measure value of the jet force might be different from the prediction due to errors in taking the reading or losses in the experiment apparatus. And for the result, we assume that the errors occur during the experiment, and then some of precautions should be taken. For example, avoid shaking the water bench so that the water level is set to a balanced position. Next is, during the experiment, the measurement taken using eye that can make errors while reading the measurement that needs to be avoided. As for the conclusion, the difference between the theoretical value and the actual value might be a bit different due to error like human error or parallax error, and the force exerted by a jet of fluid on a flat or curved surface can be resolved by using the momentum equation, which is Fy equal to rho times Q times V times cos theta plus 1. That's all from me, thank you.